We often take for granted the whir of a fan or the spin cycle of a washing machine. These everyday actions are powered by a marvel of engineering, the electric motor. Electric motors are everywhere. They are the unseen engines driving countless devices in our homes, workplaces, and beyond. From tiny motors in smartphones to massive ones powering industrial machinery, they have become indispensable to modern life. But how do these silent workhorses actually function? The secret behind the electric motor lies in the fascinating relationship between electricity and magnetism. It's a dance, really. This intricate dance is what powers so many of the devices we use every day, from household appliances to industrial machinery. But how exactly does this dance work? Let's delve deeper into the science behind it. When electricity flows through a wire, it creates a magnetic field around it. This phenomenon is known as electromagnetism. The magnetic field forms concentric circles around the wire, and its direction depends on the direction of the electric current. This is a fundamental principle that was discovered by Hans Christian Ørsted in 1820, which laid the groundwork for the development of electromagnets and electric motors. This magnetic field can then interact with other magnets. When a current-carrying wire is placed near a magnet, the magnetic field generated by the wire interacts with the magnetic field of the magnet. This interaction can cause forces that push or pull the wire, depending on the direction of the current and the orientation of the magnetic fields. This is the basic principle behind the operation of electric motors. In a motor, we strategically place coils of wire, electromagnets, within the field of a permanent magnet. These coils are usually wound around a core to enhance the magnetic effect. When electricity flows through these coils, they become electromagnets with their own magnetic fields. The arrangement of these coils and the permanent magnets is crucial for the motor's operation, as it determines how the magnetic fields interact to produce motion. By switching the direction of electricity in the coils, we can manipulate the magnetic forces. This is typically done using a device called a commutator in DC motors, or through electronic controllers in AC motors. By rapidly changing the direction of the current, we can ensure that the magnetic forces continuously push and pull the coils in a way that produces a smooth rotational motion. This precise control of the current direction is what allows electric motors to operate efficiently and effectively. This causes the coils to be pushed and pulled, resulting in rotation. The continuous rotation of the motor's shaft can then be used to perform various tasks, from turning the blades of a fan to driving the wheels of an electric car. The beauty of this system lies in its simplicity and reliability, making electric motors an indispensable part of modern technology. So, the next time you see an electric motor in action, remember the elegant dance of electricity and magnetism that makes it all possible. Just like there are different types of batteries, each designed for specific needs and applications, the world of electric motors is equally diverse and fascinating. Batteries come in various forms, from the small button cells that power our watches to the large lead-acid batteries used in cars. Each type of battery has its own unique characteristics such as voltage, capacity, and discharge rate, making them suitable for different tasks. Similarly, electric motors are designed with specific purposes in mind, and understanding these differences can help us appreciate the technology that powers our modern world. There are different types of electric motors, each suited for specific purposes. Direct current DC motors are simple and reliable, making them ideal for applications where precise control and ease of use are important. These motors are commonly found in toys, small appliances, and even some types of industrial equipment. Their straightforward design allows for easy integration into various devices, providing consistent performance with minimal maintenance. DC motors operate on a straightforward principle. They convert electrical energy into mechanical energy through the interaction of magnetic fields. This simplicity makes them highly reliable and easy to maintain. However, they are not the only type of motor available. Alternating current AC motors, on the other hand, are more powerful and efficient for larger applications like industrial machinery. These motors are designed to handle higher power levels and are often used in settings where robust performance is required. AC motors are the workhorses of the industrial world, providing the muscle needed to drive heavy machinery and equipment. They operate on the principle of alternating current, which allows them to deliver consistent power over long periods. This makes them ideal for applications such as conveyor belts, pumps, and fans, where continuous operation is essential. The efficiency and durability of AC motors make them a popular choice in many industrial and commercial settings. And then we have brushless DC motors, a newer breed known for their efficiency, quiet operation, and longer lifespan. These motors eliminate the need for brushes, which are a common wear point in traditional DC motors. By using electronic controllers to manage the motor's operation, brushless DC motors offer improved performance and reduced maintenance requirements. They are commonly found in electric vehicles and computer hard drives, where their efficiency and reliability are highly valued. Brushless DC motors are revolutionizing the way we think about electric propulsion and precision control. In electric vehicles, they provide the power and efficiency needed to extend driving range and reduce energy consumption. In computer hard drives, they ensure smooth and reliable operation, protecting valuable data from potential damage. As technology continues to advance, we can expect to see even more innovative uses for these versatile motors, driving progress in a wide range of industries. Think about your average day. You wake up and the coffee grinder whirs to life thanks to a small electric motor. At work, the elevator whisks you up to your floor using a powerful motor. Even the escalator at the mall depends on these tireless machines. In factories, giant robotic arms guided by precision motors assemble cars and other complex products. Electric motors truly are the unsung heroes of our modern world. As we move towards a more sustainable future, electric motors are playing an increasingly important role. Their high efficiency and ability to run on renewable energy sources make them ideal for reducing our carbon footprint. Advancements in motor technology are constantly pushing the boundaries of efficiency and performance, paving the way for a cleaner, greener world. While electric motors offer a pathway to a more sustainable future, it's important to acknowledge their energy footprint. Currently, electric motors consume over 40% of the world's electricity. That's a huge chunk of our global energy consumption. As we electrify more of our world from cars to homes, the demand for electricity, and therefore the energy consumed by electric motors, will only increase. One of the most exciting applications of electric motors is in electric vehicles, or EVs. By replacing gasoline engines with electric motors, EVs drastically reduce harmful emissions. As battery technology improves and charging infrastructure expands, EVs are poised to revolutionize transportation and contribute significantly to a cleaner environment. Electric motors are also essential for harnessing the power of the wind. These motors are the unsung heroes behind the scenes, making sure that wind turbines operate efficiently and effectively. Without them, the process of converting wind into usable electricity would be far less efficient. In wind turbines, they serve a dual purpose. The first role of these electric motors is to adjust the direction of the turbine blades. This is crucial because the blades need to be aligned perfectly with the wind to capture the maximum amount of energy. First, they adjust the direction of the turbine blades to face the wind, ensuring optimal energy capture. This process, known as yaw control, involves rotating the entire nacelle, which houses the generator and other key components, to keep the blades facing the wind. This constant adjustment is vital for maximizing efficiency and energy output. Second, they convert the kinetic energy of the spinning blades into electrical energy, feeding it into the grid. This conversion process is where the magic happens. The kinetic energy from the wind turns the blades, which in turn spins a rotor connected to a generator. The generator then converts this mechanical energy into electrical energy, which can be used to power homes, businesses, and industries. As we transition away from fossil fuels, wind power, driven by electric motors, will play a crucial role in our energy mix. The importance of these electric motors cannot be overstated. They are the backbone of wind energy, ensuring that we can capture and convert wind into a reliable and sustainable source of electricity. With advancements in technology, these motors are becoming more efficient, durable, and capable of handling larger and more powerful turbines. This means that wind energy will continue to grow as a key component of our renewable energy future, helping to reduce our reliance on fossil fuels and combat climate change. The story of the electric motor is far from over. Researchers and engineers are constantly innovating, developing new materials, and refining designs to make motors even more efficient, powerful, and compact. From tiny micromotors used in medical devices to massive motors powering ships, the future holds exciting possibilities for this versatile technology. As we continue to explore and harness the power of electric motors, we pave the way for a cleaner, more sustainable, and technologically advanced future.